This video is intended to help you fill out the notes and understand graphing inequalities. Let's get started. First, we're going to start off like we always do, recalling some information that we already know. We already know that an equation, let's write this down, an equation it's a mathematical statement where two values or two expressions are set equal. So again, equation starts with that word like equal, and the big thing is it will have an equal sign. Okay, if it doesn't have an equal sign, then it's just an expression, right? So if I said 2x equals some value, I'm saying that 2x, the thing on one side, has the same value as the thing on the other side, whether it's a number or another expression. Now, how is that different from an inequality? We've seen inequalities before. Inequalities are also statements, and it relates two values to one another. But they're not going to be equal, okay? It's not an equation. They're not equal. They're unequal, okay? So they're not the same. That means they're going to be greater than, let's look at this. It's going to be greater than, could be less than. We could also have situations where the statement says it's greater than or equal to, or less than or equal to. And a solution is a value for the variable that makes a statement true. That makes a statement true. So you don't have to write this down, but let's think of just a quick example here. So if I said 2x equals 6, well, we know if we divide both sides by 2 that we would say x equals 3. And we would know that this is the solution to this equation, because if I plugged x in, the value 3, then I would say 2 times 3 equals 6, does it? Well, 2 times 3 is 6, and on the right side we have 6. They are indeed equal. So that's an example of a solution. Okay, let's get back on track. A number line. We're going to recall this. This is something you've used for a long time in math, and just an example of a number line. It's just one line. It's got arrows on each end. And for our purposes, we're probably going to have 0 in there and some positive numbers and also some negative numbers because we work with integers. But it can also have different increments. Like I could say this is negative 1.5 and this is positive 1.5. But we're not going to be dealing with decimals today. We are just going to be talking about a number line and how we use that to help us view problems. Last week we worked on plotting solutions to an equation on a number line. So for example, let's find that equation that we did just a minute ago. We had, we said 2x equals 6. And we know that if we divide both sides by 2, that x equals 3. And we believe that's true because if we plug x in, we would say, we could say 2 times 3 equals 6, and 6 does indeed equal 6, so we know that's true. So if we had a number line and we needed to plot the solution, we would say, well, where what spot, what one number, one dot on this number line makes this true. Oh, that's probably not the best. Now, I'm going to plot on here. I know that my solution was x equals 3. So I would say, well, right here at 3, this makes it true. And that's all I have to do to plot the solution to an equation on a number line. It's just one single spot. If I put the dot anywhere else, like for example, if I said, oh, I think it's 1, well, then I could always check that and say 2 times 1, does that equal 6? Well, 2, 6, no. So we know that that is not the right answer. Okay? So let's consider that a point, let's write that down, a point indicates that there is one single solution to an equation. We just did that where we dotted it on there. But what we're thinking about today is that an inequality can have more than one answer that satisfies the statement. More than one answer. So let's say if I just change that last example up a little bit, and I said instead of 2x equals 6, I'm going to say 2x, whatever that value is greater than or equal to 6. Well, we saw last time that x could be 3, okay? And that gave us 2 times 3, is that greater than or equal to 6? Yep. But what if I said x equals 4? Well, 2 times 4, is that greater than or equal to 6? Well, 2 times 4 is 8, which is indeed greater than 6. So if I were going to try and plot that out on a number line, it'd look a little bit different because just that one dot on 3, that would only satisfy the equal part, but not the greater than part. So how that looks different on our number line is we're going to have that same number line that we had before, and let's see, I think I started, let's just do -1, 0, 1, 2, 3, 4. You can make as many spots on this as you want, as long as you have the ones that we're looking at on there. I don't really care. And we said that 3 works, but so does 4. And by that logic, anything bigger is going to work, and any little spot in between it is going to work. So we know that not only does 3 work, so we're going to put our solid dot there, but also everything greater than 3 also satisfies that equation. So we have to shade in every single thing past there. Well, our number line has an arrow on the end indicating that it keeps going on and on because 100 could also be an answer. 2 times 100 is greater than 6. So we're going to go ahead and shade in the arrow at the end. So basically, we included the dot because it could equal 3, but it could also equal any spot on this line. And we don't want to just put dots on the numbers because it could be the fractions in between there as well. So let's review what these signs are. Let's say we know that we always read math left to right like we do reading a book. So greater than looks like this. It looks like this. Greater than or equal to has that greater than symbol, but it's also got an equal to symbol under it. So the line underneath the greater sign indicates that it could be greater than that number, but it could also be that exact number. It could be a large set of numbers. And less than simply points the other way. Some people say it kind of looks like an L, but less than looks like that. And we would also indicate less than or equal to the same way. It's got an equal bar under it, saying that it could be this one on top, less than, or it could be exactly equal to. How does that affect us when we're graphing? Well, when we're graphing, we're going to say greater than. So remember, greater than looks like this, greater than. So we're gonna graph that instead of a dot like you would if you were just going to plot a point that's saying this one answer is correct. It's got to be this one right here. Greater than, we're gonna just make an open circle, and we're not gonna fill in the middle because it says this number is important. It can be anything greater than this, but it can't be this. It's only numbers greater than this. So we're going to leave an open circle, and then we're going to draw a line, or we're going to shade in the number line to the right, and we will include an arrow on the end. That says anything bigger than this point is going to satisfy what we're looking for. And that's going to be a little bit different than the next one, which is greater than or equal to. Remember, it could be greater than, or it could be exactly equal to. Well, we know how to graph something that's exactly equal to. That is a closed circle. That's that point or that dot. So that says it could be that exact number that it's sitting on the number line, but it could also be any number that's greater than this number. And we want to put an arrow on the end because it could be way down there at a number that we don't see. Following that same logic, if we look at less than, remember it kind of looks like an L, less than, we're going to also include an open circle for that because it's saying, well, this number is important because any number less than this is going to be my number, but this number can't be it because it's not equal to, it's just less than. And then we will also shade that to the left because we know that values that are less than on a number line fall on the left. That's where our negative numbers go. We get further and further to the left, the numbers get smaller and smaller. And just as you might have guessed, less than or equal to is exactly the same way as greater than or equal to, only we're going to indicate it could be exactly equal to this number that we're putting it on the number line, but it could also be any number less than this, and it could go on and on and on to numbers that we don't even see printed on our number line right now. Okay? And the shading is important. If you do not shade either to the right for a greater value or to the left for a less value, then you're not including all the numbers in the set that make the statement true. So let's try it together. So first, let's read this. This says 8 is less than m, and I'm going to give you a tip here. This is something I want you to always try to rewrite with the variable on the left. Does it change the value? Absolutely not. The value is still going to be the same. However, since we read left to right and we're graphing like we're reading left to right, the easiest way to see something is to make sure that we're reading the variable first. So when I flip this around to say m first, I still have to have the open side facing the m. So now we're going to say instead of 8 is less than m, we're just going to read it that m is greater than 8. And those statements mean the same thing, right? So if 8 is littler than m, then we can also say that, well, m is bigger than 8. So first we're going to recognize we wrote it, we made sure our variable is on our left side because that's just an easier way to look at it. You could do it the other way, but I'll show you why here in a second. So m is greater than 8. So I need to find 8 on my number line. And then I have to remember, well, am I going to use an open circle or closed circle? Well, we know that when we've got an equal sign, we can close that dot and say this number works. But there's no equal sign on the bottom of this. So we're going to go ahead and do an open circle at 8. And this says m is greater than 8. So anything bigger than 8 would make this statement true. So I'm going to go ahead and shade everything to the right, including the arrow on the end. Okay? And that says that 8 is not greater than 8. That's why my circle is open. But 9 is greater than 8. 10 is greater than 8. 15 is greater than 8. 115 is greater than 8. All of those things apply. So remember that if there's no equal sign, you can't fill in the dot. Now let's try number 2. This time it says 6 is greater than D. Well, we know if 6 is greater than D, then D is less than 6, right? Because we just have to make sure that now it's pointing at the D. We have to continue pointing at the D. We can't change the value of it. We're just rewriting it. So here, D is less than 6. So I know 6 is important, so I'm going to circle it. But I'm not going to fill it in because I couldn't say that exactly 6 is less than 6 because 6 is not less than 6. It's equal to 6. But I know any value smaller than 6, any value smaller, therefore to the left on a number line, is less than 6. And we know that's true because 5 is less than 6, 3 is less than 6, 0 is less than 6. All of those other values, including ones we don't see like negative 10, that's also less than 6. Now where number 3 and number 4 are different, you'll notice that they do have that piece of an equal sign underneath. So here I've got y is greater than or equal to 9. So if I'm going to plot that, I'm going to find 9 because 9 is important. So since it could actually be 9, well, I'm going to say 9 is important, so I'm going to circle that. But it could actually be exactly 9. 9 is greater than or equal to 9. But what else satisfies that? Every number to the right. 10 is greater than or equal to 9. 11, 15, 215, all of those numbers to the right. So I have to make sure I include that arrow. And the same way with G is less than or equal to 9 here. Well, here I'm going to circle my 9 because 9 is what's important. Could it be exactly 9? 9 could be less than or equal to 9, so I'm going to fill that in. And then I have to include every value that's less than 9. So I'm going to shade everything to the left, including the arrow on the end, because my graph only goes down to 0, but negative numbers are less than 9. Negative 1 is less than 9, so I have to make sure I've indicated that that is included. Okay? So let's recap. Equal to looks like this. It means it is exactly that. It is exactly whatever value. And we graph that. How do we graph that? With a closed circle or a point. So it looks like that. Greater than looks like this, and it says that the thing on the left is bigger than the thing on the right. And how do we graph that? Well, it's not the same, it's bigger than it, so we have to use an open circle, right? Open circle, but it's not just that number we're talking about, it's everything bigger than that, everything to the right. And the reason I said we're gonna go ahead and, here, let's backtrack just a second. If you notice on these, when we write the variable first, and only when we write the variable first, so here m is greater than, you see it's kind of pointing to the right, and we shaded to the right. Here d was less than, it was pointing to the left, and we shaded to the left. Y is greater than or equal to, points to the right, we shade to the right. That will always work, that it'll point the direction you're shading if your variable is written first on the left side. Now, if we just read it the way it is here, where we said 8 is less than m, well, it kind of looks different. We may not get that same intuitive sense that what we're really doing is shading a number that's greater than. So it's just easiest if we put the variable on the left. Okay, now back to that. So greater than is an open circle, and you're going to shade to the right, including the arrow, because you're looking for all the values that are bigger than or greater than. Less than kind of looks like an L, and that means that the thing on the left is smaller than or less than the thing on the right. And we're gonna also leave that as an open circle because it's not that exact thing, it's only things smaller than that. So we'll open circle and we'll shade the things smaller than that. Now, when we see these double duty ones here, like greater than or equal to, we have to satisfy where it's greater than and also where it's equal to. So since it could be equal, exactly equal to that, we're going to close the circle. So we're going to have a closed circle. So we're going to have that dot just like an equal to. But then we also have to have the arrow that says greater than, because it could be that dot, but it could also be the next number or the next number or the next number, all the way to the larger numbers. And in that same logic, less than kind of looks like an L, or equal to is also going to have a closed circle, and it's going to point to cover all the values that are less than that, which on a number line lie to the left. So basically everything you need to remember about graphing an inequality is right here. You need to remember whether the circle is closed or open, and that the circle lands on the number that we're focusing on, but the shading tells us, well, it could also include these numbers in the set. So finally, there are 4 practice problems for you to do on your own. You do not have to submit these, but you do have to do them. So I'm going to just recommend that you first rewrite with the variable first, or the variable on the left side. Then you're going to use your circle on the focus number and shade. So you'll be shading to the left or the right, and remember to get those arrows on the end.